Good morning. This is Aruna from CSC Regular. I am discussing about the topic is multimedia databases. The need of multimedia databases. The earlier previously MMDBMS presentation requirements. Example is the employee database or employee photo. Sales online catalog product pictures, sorting images files externally to database and storing its difference in the database. Coming to the multimedia applications evolving, people wants to exploit media data in nature way and retrieving the manipulating the data, and complex appliances are developing video on demand entertainment services, groupware and surveillance and telemedicine. And essentially requirements for the advanced multimedia databases is to search and manipulate the content of the pictures, sounds and video as early as text data to retrieve the data needed. Different about the multimedia data, three changes are arise from the multimedia data. First one is the size, and second one is the time, and third one is the complexity and semantic nature. And coming to the size is affects the storage and retrieval and transmission of the multimedia. And size of one good quality colored image, that is the 6 MB. A video object sequence of image frames 30 frames by seconds, 5 minutes. That the video clip is the 54 GB. And coming to the audio sequence, 8 KB for each second. Text image is 1 page to up to 10 pages, 100 of pages. Therefore, technique that reduce the size of multimedia data without impacting on the information within the data are clinically. Next one is the time. Time cannot be run back. Sequence and speed, that is the acceptance rate, is important and is not considered become meaningless. Parallelly, audio and video continues periodic media. Relationship with the time, way how media objects are stored and retrieved and transmitting and synchronized together. Real time and nature of the multimedia. The conversation is real time. Real time effects will be it will be noticeably when we manipulate the data in database. Example, video clip of an interview, audio and video image synchronized together. Next one is the complexity in the semantic nature, difficulty in identifying the components within the media. Simple solution, describe of words for content in each image. Example, image of product plus text describing it. Meaning and content is important. So, interpretation may need to made based on certain features of multimedia data and stored as metadata. Metadata deals with content, structure and semantic of data. And users querying multimedia data. In multimedia query, text description of image or video clip will be provided. Solution to the problem of query, design lines with analysis of users' needs. Users may need images to convey the information or emotion. They are difficult to communicate in words. Visual information in queries results in different ways of constructing the queries and searching the data. So, the 4 combinations of query search modes. These are adopted by the multimedia retrieval system. First one is the uniguist mode. That means SQL searching for the text. So, locate and retrieve the requirement multimedia information. Titles, keyboards and captions offer limited retrieval possibility. Next one is the visual, that means a visual mode. Retrieval by content, example, query in form of sketch users draw. User manipulate the basic leaf shapes, return attributes matching images and returning in rank order of attributes, facial recognition. Next one is the visual uniguist mode. That means images retrieved by the uniguist metadata. Next one is the uniguist visual mode. So images are indexed by visual attributes, user queries in unused form of using SQL. Next one is the multimedia applications. Multimedia applications we are using entertainment, that means a video on demand. Next one is a public protection, that means a face recognition, fingerprint and video surveillance. Next one is the medical information system, that means the X-ray, ultrasound and scanning. So these are the applications. Next one is the multimedia data acquisitions, that means data capture, example achieving by the photograph, film. These methods do not interrupt us, but the way in which the data is subsequently processed is important. Sampling the analog signal and converting it into digital value so that the result is a digital representation of the original. Next one is reducing the media object size. By data compression, predict a model and transform allows the digital data to be compressed and reduce the size. And predict model, that means that estimate how much the redundant data exists that could be removed in this way, and the best selection algorithm. Next one is the transform, store in one format but need to be transferred to other format for transmissions. So when the image is restored and decomposition. These are the reducing the media objects and size. Next one is how large is video object. First one is the compression can make the video data manageable without much loss of quality. Two potential methods for reducing the size of the video objects. Spatial compression, use useless space for each frame by sending less detail. Temporarily and spatial compression and reduce the number of frames because a little is moving. Next one is the MPEG standard for video compression and categorize three main types of frames. First one is the L frame, that decomposition depends only on the true information inside the frame. Next, P frames coded with reference to a previous LRP frame. B frames, bidirectional frames are coded with reference to previous or subsequent PRL frames. Next one is the real-time nature of the multimedia. First one is the video segmentation. The process of subdividing the video object need to detect the redundancy between the camera shoots. Next one is the shoot, sequence of frames captured by single camera in a single continuous action in time and space. Next one is the cut, the transmission between the shoots that occurs between two adjacent frames. This is the easy to detect. Next one is the fade, gradual changes in brightness either starting or ending with the black frame. Next one is the dissolve, similar to fade except it occurs between two shots. Next one is scenes, logical grouping of shoots into systematic unit. Next one is the clip, two properties, sequence and continuous video frames. Segmentation of video in sense lot more useful than segmentation of video into shoots. Semantic nature of the multimedia data, a problem. Multimedia data, images, videos and audio clips have an explicit semantic nature. Metadata references to information about the individual object. Specific metadata for different types of raw data include sexual of images, frequencies for audio, font size for text. Next one is the motion direction and lighting for video. Next one is the speech, keywords such as identification of speakers, place time. Next one is the video clip, camera motion and lighting. Next one is the generation of metadata is costly and useful carry out after the raw data has been stored. Next one is the three classes of metadata. First one is the manual generation of metadata, that is the segmentation and sense cuts. Next one is the semi-automatic methods of generating of data. Next one application domain, content of data, and uses purpose. Next one is the automatically generated the metadata, that means the time and place of photography. Metadata needs to be updated when the raw data is changed. This is required explicit knowledge of structure and semantic of metadata. Next one is the manipulating large objects. There are three approaches to manipulate an LOP and WARKL. Using WARKL API, using DBMS LOP packages. Next one, using the WARKL call inferences. This is the creating table, grape table creating. First, that is the grape name. Grape name is the variable name, that is data type is varchar2, size is 30, and grape text color default empty blob. Next one is the picture blob, default empty blob. Constraint primary key is the grape name. Grape name is the primary key, that is not repeat the values, there is no duplicate values. We need to use the PL SQL function and procedures to manipulate LOBs. Since there are few SQL built-in functions available for multimedia data. We must retrieve its locator value before we can process an LOB. Simple procedure to retrieve an LOB locator. Create or replace retrieval LOB is grape blood. Begin. Next one is a begin, that we select the picture into grape pitch from grape, where grape name equal to Cardone. Next one is the end. End is the begin, and next one is the end. We can get rid of data in claw by using the statement update grape, set grape text equal to empty claw, where grape name equal to Corondone. If instead we use the B file type, there will be a number of ways in which the photographic data can be added to the database. Grape text column, picture B file. B file is externally stored in the file system, which could be CD-ROM, now network drive, and extra. Before using the B file, creating the directory object, which is used to align to physical OS directory that contains the actual B file. Create the directory, that means the audio directory that is stored in C drive audio. Next one is the create directory, photo directory, as C it is stored in the images. Read the directory, photo directory to Scott. Next one is the inserting. Insert into grape name, pictures, value. Next one is the Corondary, and next one is B file name, that is a photo directory. Next one is the Corondary JPG file. And next one update grape, set picture equal to B file and photo directory, Corondary and JPG. Next, these are the multimedia databases. Thank you.